Hi guys, how are you doing tonight? Hope you're having a great day. Today we're going to take what we've learned about parallel lines and their related angles. We're going to use that to prove that lines are parallel. So that's what we're going to learn today, how to prove lines are parallel. What I want you to do is I want you to take each of these four statements, just take a minute and write the converse of each of those statements. So if two parallel lines are cut by a transversal, then corresponding angles are congruent. Okay. They all should start with, basically, if two parallel, in fact, I'll give you a first example. If two lines in a transversal form congruent, corresponding angles, then the lines are parallel. So we know that to be, if I've got these corresponding angles, if I say that 2 and 5 are congruent, then I can say that these lines are parallel. Remember that that symbol means parallel. So go ahead, I've written the first converse for you. You guys go ahead and pause the tape and write the next three converses. When you're ready, then start the video again. All right, so now the alternate interior angles theorem says if two parallel lines are cut by a transversal, then alternate interior angles are congruent. The converse says that if two lines in a transversal form congruent alternate interior angles, that's a mouthful, right? Then the lines are parallel. So we could say that if 4 is congruent to 5, that those lines are parallel. And remember again that the arrows mean that they are parallel. The next alternate exterior, the converse. If two lines in a transversal form congruent alternate exterior angles, then the lines are parallel. And the last, the same side interior or consecutive angles theorem. If two lines in a transversal form supplementary same side interior or consecutive angles, then the lines are parallel. So remember that if 4 and 6 add up to 180, then we can say that the lines are parallel. So they've got to add up to 100. And the same with angles 3 and angles 5. So I have got these lines, a whole bunch of them, and which ones of them are parallel? Take a minute, think about it, and see if you can figure it out. If I'm looking at this line right here, and sometimes colored pencils really come in handy, these angles right here, they're on either sides of O, and then it looks like it's on the outside of RP and SQ. And they are, okay? So that means that we don't need this line, so sometimes we like to put in extra things. These colored pencils can really help me see, okay, that I've got alternate exterior angles. So by that converse of alternate interior angles, that I want you to know the difference. Okay, so the converse of our alternate exterior, we're going to say that P, line P, is parallel, those are our symbols, to Q. So by the converse of the alternate exterior angle theorem, P is parallel to Q. Let's look at our next example. Got this angle, looks like they're alternate exterior again. Alternate, and here are our lines T and U. So absolutely, this is going to be the same thing, the converse of the alternate exterior, and we're going to say that T, and I always make a cursive, is parallel to U. So there is two examples that we could use those to justify. Another type of problem that we typically see is to determine the value for X for which R is parallel to S. And then we want to find the measure of each labeled angle. So we just want to find the measure of this angle right here. Okay, so again, we know that we've got this going on right here. So that means that those two angles should add up to 180 degrees. So 4x minus 8 plus 112 equals 180 degrees. So if I combine my like terms, negative 8 plus 112 is 104. So 4x plus 104 is 180. And if I subtract 104 from both sides, I'm going to get 76. So 4x equals 76. And if I divide by 4, we're going to equal 19. X will be 19. So if x is 19, then we could either sub it back into the 4x minus 8 to find the measure of that angle. So 4 times 19 is 76. And 76 minus 8 is 68. So that's going to be 68 degrees. And if we wanted to, we could double check, because we know that these two angles should add up to 180 degrees, and they do. So we're good. All right, so now I talked to you about, we've learned two-column proofs, we've learned paragraph proofs, and now we're learning flow proofs, which I despise, but that's okay, to each their own. Okay, in a flow proof, we have the statements inside the box and the reasons outside the box. Okay, so you kind of have to fill it in. I've got x parallel to y, and that's given to me. So I've got that. I'm going to mark it. From there, I'm saying that same side interior angles are supplementary. So the only same sides we have are the measure of angle 2 and angle 3. So that would go in here, the measure of angle 2, or we could just say, actually not even measures, we could just say that those are supplementary. So we're going to say that angle 2 and angle 3 are supplementary. And then we're going to say down here that the angle of 1 and angle 2 are supplementary, and that was given to us. Those two put together give us that 1 is congruent to 3, and that would be by the congruent supplement theorem. Oops, congruent supplements. Basically says if an angle is supplementary to two different angles, then the angles are supplementary. 3 is congruent to 4, so right now we've got 1 congruent to 3, and I'm going to mark it. We've got 3 congruent to 4, let's mark that, and that is by vertical angles are congruent. Okay. And then we are going to use the transitive property that says angle 1 is congruent to angle 4. So it means that these two, this and this taken together, we're going to get rid of the middleman, right? Gives us angle 1 congruent to angle 4. And from that, we're going to say that Q is parallel to R. And we can do that by the converse of the corresponding angles theorem. So we have taken a flow proof and we have proved this. Definitely my least favorite kind of proof. I think it doesn't tell enough, but that's just me. And again, you guys know me, I am a logical thinker. I like to see things in a nice, neat line, which is why I really like the two-column proofs. All right, so what did you learn today? You learned that the converses can be used to prove that lines are parallel. The corresponding angles postulate, the alternate interior angle theorem, the alternate exterior angles theorem, and the same side interior or the consecutive angles theorem. So we learned a couple ways that we can prove that lines are parallel. Have a great day.